I'm going to give you a definition now of the intermediate value theorem, which is a really useful theorem, especially when you're trying to determine the behavior of a graph, particularly if you're trying to find intercept values or zeros of a function. So the intermediate value theorem and if you think about the name intermediate value meaning an in-between value, says the following. It says let f be a continuous function. Okay, so let f be continuous on some interval, a closed interval, a b. Okay, so the reason that we don't say an open interval, you should probably take a look at why we don't say an open interval. Okay, and I can talk about it too, but I think it's better if you investigate it. And suppose that for some number c, that the function at a is less than c, which is less than the function at b. If this is true, then there exists some x naught in the open interval AB such that the function evaluated at x naught is equal to c. Okay, so big picture, what's this saying? Let me draw what's going on here. Let's say we've got some interval, some closed interval from here to here. Okay, and let's say, so let's call this endpoint A, this endpoint B, and then let's also say that f of A is at a height, I don't know, right here. Okay, so this height right here is the function evaluated at A. And then let's say over here somewhere is some height value. Let's call this guy f at b, okay? Now clearly it's the case that f of a is less than f of b. Now, f is continuous, which means, graphically, it means that to go from here to here, I can do whatever I want, I just can't make any jumps or any breaks in my graph. So now let's say there's some height value c. I don't know, c is between f of a and f of b, so c is maybe right here. Okay, so here is c. What the intermediate value guarantees is that there's some point inside of this interval right here, there is some guy somewhere in here such that when you evaluate the function, you end up passing through this line. So let me make this line solid here. So that's at a height value of c. Now I need to go from this point to this point without lifting my pencil. So no matter how I do that, I eventually have to cross. And that point where we cross, that is x naught, and we decide that f at x naught, right here, f at x naught is equal to c. So what we found was some guy on this interval that matches up with this right here. So, well, how can you use that? Let me just show you here. Let's say we know that a function's continuous, and we know that at some point it's below the axis and some point it's above the axis. Then since it's continuous, we know that at some point it has to reach a height value of 0, which tells us that there has to be an x-intercept, there has to be a 0, the function on that interval.